Yeah, so my name is Devine. I am the CTO. I'm the VP of the Cloud Services Division. That was the division that SoftLayer was acquired into at IBM, and I led the technical due diligence of that. One of the things that made SoftLayer the right asset for IBM was because it was the perfect platform for many of the things that goes into the Internet of Things ecosystem in terms of being able to have a dedicated, intense I/O capable infrastructure that you could deliver data and analytics, which are very important to the IBM company. And then also being able to have a global networking footprint such that you could deliver quality of experience end to end. All right? So like with any of my presentations, the most important one chart is the first chart. It's got my contact information. So feel free to reach out, email, Twitter, questions, comments, suggestions, anything's fair game. So let's get going here. So when we look at what's driving organizations today, there's a massive amount of change in the system, energy in the system. And a lot of it is kind of been generated primarily from the way business needs to interact with the consumer. It all kind of started with the mobile phone. You don't have to have been in the IT industry for very long to realize the change in dynamic of how consumers expect to interact with services. And when you had a mobile phone, you had an individual that had more compute power in their hands than it took NASA to send a man to the moon. So enterprises are trying to figure out, how do I take advantage of that kind of compute power? And so you had this massive move towards what we call kind of a mobile first initiative, where people were focused on delivering things to the mobile device, interacting with their consumers through the mobile user. And the behavior of the user also changed because I call it, is there an app for that kind of generation? When people had a problem, the first thing that they did was they looked for an application to go solve that problem. So it was all about consuming services that were delivered, and they were doing it in a real-time fashion. And so now when you see what's happening with Internet of Things, you can just take that those dynamics that happen with mobile, and you can multiply them by a factor of 100, or maybe it's a factor of 1,000, or maybe it's a factor of 10,000, where you not only have an Internet of people, but you have an Internet of devices that you need to interact with in real time. And that's dictating fundamental changes in the way you do things. And so I love this quote by Albert Einstein. It says, if you always do what you always did, then you'll always get what you always got. All right? And that was the trap that we had. You almost needed something like the mobile phone revolution to kind of shake things up, to disrupt the status quo, because we've kind of got lulled with enterprise IT of doing things the same way at the same pace, very regimented pace. All right? And it was dictated, the rate and speed at which you had to interact with your consumer dictated a different architectural model. I'm going to talk about that a little bit later. So we had these market shifts, this aspect of a digital economy. I did a presentation about a year and a half ago at a business API conference. And it was interesting. It was a room sort of like this, but it had just two sections, row down the middle. And on one side, it had people in T-shirts and blue jeans, and I even had a couple of flip-flops and tie-dye T-shirts over there. And then I had suits and sport coats over here. It's a very odd dynamic. So what in the world brought developers and business people together was this aspect of doing things in real time, being able to interact in new and interesting ways. You had the agile developers that wanted to build applications faster. You had business people that wanted to respond to business opportunities more quickly. All right? So this aspect of changing into a digital economy, being a digital enterprise, being a digital company, I used to say that if you didn't start this migration towards moving into a digital world, that two guys in a garage could take you out. And I had one conference I was speaking at, somebody raised their hand and said, you don't need a garage. And they're right, you don't need a garage. All right? Because the cloud gives you the ability to build things very, very rapidly. And because of the changes that happen with dealing with mobile applications, you get this very scale-out distributed architecture where things happen at the edge, things happen at the back end, they need to be synchronized. And so this brings us to what I call the need for cloud speed. So the rate and pace at which things need to happen is significantly different than it was before. I remember when I first started working with IBM about 25 years ago, we considered things that were legacy five years old. Right? Now, something could be legacy and it could be 5 days old or 5 weeks old. All right? You have the ability to utilize technology like never before. You don't want to be trapped into something and then have some new technology come out of stealth mode and blow you completely out of the water. So this ability to not highly customize and tightly integrate applications, but have more of a loosely coupled API orientation to the architectural model is really what's made mobile first possible. And that's what I believe is going to also lay the foundation for the Internet of Things. And then you have this aspect of data. Who has the data has the ability to have the insight to go solve problems that their competitors cannot. All right? But that's the key. That's why I talk about this perfect storm. If you just collect data and you have no insight from that data, you just have a big mess of data. All right? It's all about the insight that you get. You got to have the right analytics. You got to have the right capabilities of maybe throwing away certain data that's bad, keeping data that's good, figuring out what to throw away and what to keep, how long to keep it. All right? The companies that do that the best, in other words, they do it the most efficiently and we do it with the most insight, are the ones that are going to be successful. All right? And so there's this great quote that I like from Ralph Waldo Emerson that says, "Do not go where the path may lead, but instead go where there is no path and leave a trail." All right? That could be applicable to APIs. In other words, I want to make this data accessible so they can be used in a greater context. In my opinion, one of the litmus tests to success today is if I can create a platform, if I can create a service that can be consumed by somebody else that I've never met and that I haven't trained, and they can turn it into something, another service that I never envisioned, that's the measure of success. Things need to be that consumable, they need to be that composable, and you need to be able to provide things that are easy to consume and easy to extend. And the companies that do that in terms of their data are going to be the ones that are successful. And it's an interesting thing. Once you kind of crack the nut in terms of figuring out how to use the data, then you just want more of it. All right? It was interesting. I had a conversation with a CIO of a very large healthcare company. They're actually in the medical research field. And they kept saying, those doctors, I hate those doctors, they keep wanting to have one more line of medical history in the family tree. But one more line of medical history in the family tree, it gives them better insight of what they can do in terms of cancer research. But that one more line of family history equates to 10 petabytes of data. And I don't know where to put it. I don't know what to do with it. All right? And so there's this real challenge. You know, how much data is too much data? How can I get the right insight from that data? And so that's really what the challenge is. The people that can understand how to use that data and use it efficiently, effectively, are the ones that are going to be successful. And that's why I say that this is perfect storm, because if you were just having to do everything yourself in enterprise IT inside your own data center, and you had no ability to tap into infinite capacity that somebody else had, then you're going to be toast. You're not going to be able to keep all the data that you need. If somebody asks for more data, you're going to tell them, I can't get any more data. All right? Even though that piece of data could be what really unlocks a potential business opportunity. So my assertion is that cloud is an enablement to be able to tap into infinite capacity, global reach, and so that you're not doing things just on your own. And that's one of the things that was so frustrating with the Agile developers or that business API conference I was talking about. They didn't feel like the enterprise IT moved at the pace that they needed to. They wanted to use new platforms. They wanted to use new frameworks. All right? But they couldn't get things out of enterprise IT fast enough. All right? And so having the ability to tap into a cloud service provider that has that kind of reach, has that advanced automation in place, has the ability to deliver things in different geographies, is the way that you're going to scale this Internet of Things kind of an architecture we'll talk about. And so we talk about this connected world. Things are more instrumented, they're more connected, and they're more intelligent. So about 9 years ago, IBM started our Smarter Planet initiative. So all of our commercials, everything's about the smarter planet, smarter planet, smarter planet. All right? What I see with the Internet of Things is the realization of a lot of those kind of visionary things that IBM had in terms of the smarter planet. Smarter traffic, smarter water, smarter city. And basically a lot of the things that we did early on, the technology had not caught up. We didn't have the ability to react in that kind of real-time fashion. We didn't have the right kind of analytics. We didn't have the right kind of database technology. We didn't have the right kind of security model. All right? And so it's taken a while for the price point for the embedded silicon to get down to a point where it really makes sense to embed these sensors. There's enough intelligence of the sensors to get the right information at the right time so you can utilize it. And so I love this quote by Gandhi. As you can probably see, I'm kind of fond of different quotes. But this one is, they first ignore you, then they laugh at you, then they fight you, and then you win. And that's pretty much what happened. I remember even myself as an IBMer, Smarter Planet, IBM doesn't sell to, smarter traffic. What does that, what does that mean? How does that matter? All right? And so you start seeing some very interesting things in terms of if I can be smarter with predicting the weather as an example, then perhaps I can affect my logistics of my trucking company as I'm in the trucking industry. All right? So that's data that maybe has nothing to do with the trucking industry, but it has an application to the trucking industry. And so what you see happening is IBM partnering with large companies that have lots of data sources, like, for example, our Twitter partnership, the Apple partnership that we announced. All right? Those are all focused on being able to have our data and analytic engines being able to interact with more and more data sources so things get more intelligence at the edge, and then we can provide that kind of value. Now, I talked about the mobile phone, all right? And when you saw what happened with the mobile phone, you had companies that were kind of stretched to the breaking point from an enterprise IT standpoint because they now had to allow their users to come in with their own devices, and many times there were multiple of those devices, and they wanted to interact with their consumers in a different way, and they wanted to interact with those mobile phones. So all of a sudden, instead of having a very well-defined, limited number of clients that you had to connect to the applications, you now had a much broader set of devices that you had to connect. All right? Now you just take that and you multiply it, and you get this Internet of Things. Because now you have embedded sensors. Sensors that are if you're in the healthcare industry, I have one company that makes sensors that go into soap dispensers. That's what they do. All right? And the reason why they do that is because in that soap dispenser, it counts the people in the operating room, and if it has a different number than the people that use the machine to scrub in, an alarm goes off. All right? And so you have very innovative solutions like that are really impactful in terms of, lowering people's insurance rates because you have less risk that you're able to take because you can show that you have safeguards in place. You can go after new business opportunities in new ways. Once you get different data sources, you can realize, perhaps the individuals that, used the soap dispenser for 30 seconds had a better result than ones that used, the soap dispenser for 15, or maybe it's some kind of anomaly that you need to go check. There's all kinds of different things. The thing that's exciting about Internet of Things is the potential is unlimited. All right? The problem with the Internet of Things is the potential is unlimited. Trying to get something that you can control and manage. There's a world of potential and a world of opportunity, and what people are struggling with is they need foundational kind of building blocks. All right? How do I get started? Because the thing that's great about cloud, and you see this true of Internet of Things as well, is that you don't know what you don't know until you find it. All right? And so getting started on that journey and discovering what's important and then being willing to shift and move to where the opportunity really is. I've met a lot of companies over the last 5 years that are startups, and almost every one of them had a vision of what they wanted to do, and the ones that were successful were willing to deviate from that vision and go to where the real opportunity was, and they followed the lead of the ecosystem. So being able to deliver something, getting feedback from the ecosystem, incorporating that feedback through a continuous delivery, continuous operations model allows you to have that ability to shift. As the market dynamic shifts, you can shift with it. And you thought it was like that with mobile. It's going to be really like that with Internet of Things because of the multiplication here in terms of the number of devices and the number of potential opportunities. So I talk about this perfect storm. I talk about how this aspect of don't being afraid of making mistakes. You just want to be afraid of not learning from them. That continuous delivery, continuous operating kind of model. I would deliver things in chunks of function. All right. I remember there's this great graphic that I wish I'd included in here. Hindsight's 2020, but it shows the traditional way we did enterprise IT and we did application development, and it has the analogy of building a car. We built all the parts, and then we waited till all the parts got built, and then we assembled it. All right. Well, the Apple model. What did Apple do? What did Steve Jobs do? Came out with the iPod. All right. Everybody was really happy with the iPod, right? It was a consumable, functional thing, all right? It wasn't just a part. It served a purpose, very limited purpose, but a purpose, all right? And then he came out with the iPhone and then the iPad, all right? So there's a progression of complexity, a progression of additional functionality, but the whole time, the people were happy with the service that they were getting, with the device that they were getting, the technology they were getting. They didn't have to wait for something that might one day be there, all right? And so being able to tap into all the different data services in terms of managed data services, in terms of analytics services, in terms of being able to tap into the cloud, you don't have to do everything yourself. And just because you tap into a managed service that somebody else is providing and you're assembling that, doesn't mean that you're locked in there forever, all right? If you do it the right way. And so this ability to deliver something that has value, get that feedback, and continuously delivering more and more value, that's what you want to be able to do. You don't want us to have this 5-year plan to go and build something that's going to one day work, because nobody knows what the world's going to look like in 5 years. All right, so the basic premises here. So you've got devices, you got networks, you got the edge compute layer, and I'll talk a good bit about that. You got data storage, applications, and then this aspect of engaging, this aspect of discovering and insight that has to happen. All right? We live in a very collaborative world. If I can't have someone take my service and collaborate with somebody else or extend it, then they're not going to be an advocate for my service. One of the best things you can do when you deliver a service, if all of a sudden somebody loves that service that's using it, and you're giving them feedback, they're giving you feedback, and you incorporate that feedback, what you actually do is you turn them into an advocate of their service. I can tell you it's happened time and time and time again. A small company gets someone that really likes what they did. They feel like they're making a difference in terms of the feedback that they're giving that company. The company's reacted to that, and they become the evangelist. They want to tell all their friends about that. Right? I mean, that's the way the world works. Right? That's what consumers expect. They want to have that kind of collaborative interaction as well. And so many times what people end up focusing on is the embedded system, the device. Or they might focus only on the back-end services. And everything in the middle is just kind of magic, kind of happens. All right? And what I'm saying to you is that it's important to understand that an Internet of Things solution is an end-to-end problem. It's an end-to-end thing that you have to determine. You have to figure out, okay, how am I going to scale? All right? How am I going to operate this thing at scale? All right? How am I going to cleanse the data as it moves from the device all the way back into the back-end system? So I'm just not getting every single piece of data from every sensor imaginable, but back in the back end, I've got the data that really matters. All right? There's that steps that go through that. So let's take a look at that. So one of the things that we did back in April of this past year is we created a consortium, an industrial internet consortium. We also created IoT World Foundation, an architectural committee. And so a lot of the big players and small players that were doing things in the IoT space wanted to get together and create kind of commonalities. I don't like calling them standards because, in my opinion, standards are they're essential, but they're not everything that you need. And the point at which a standard develops, you have a point of maturity in that particular space. And things are happening so fast here, you don't want to really create hardened standards, if you will, too soon. At the same time, you don't want it to be the Wild West, and there's actually no rules at all. All right? Which was kind of where we were about a year ago. All right? And so what you want to do is what I call centers of gravity. Things that the ecosystem can be attracted to, and the ecosystem can help influence and mature. All right? So not a bunch of smart people getting in a room and figure out this is the standard and everybody has to align to that, but having this continuous delivery, continuous operation model where we get feedback from the community, incorporate that feedback, and the community helps those things mature. All right? And so we try to do that through that committee and through the consortium that we have. All right? Now, as part of that work that we did in the IoT World Forum Architectural Committee, we came up with what we called our Internet of Things architectural reference model. All right? Now, we debated for a good while on whether to call this a reference architecture or call it a reference model. We finally chose a reference model because of that dynamic that I just talked about. Things are very fluid. They're dynamic. Things are changing. All right? So we don't want to be too prescriptive that this is the one way you have to do it. Because maybe what you have to use in oil and gas is completely different than what you have to use in transportation. The on-premise implementations are significantly different in terms of the operational technology that's used for managing a plant, a manufacturing plant, significantly different than managing a mine, as an example. All right? So we have this reference model, and it's kind of humorous, in fact. I remember when we first started talking about this reference model, you know, it was the Intel guys, the Cisco guys, the IBM guys, and of course we came up with a 7-layer architectural model because we're all like TCP/IP people, right? It's got to be 7 layers. 7's a perfect number, you know. If you read the Bible, 7's a perfect number, so it's a great number, all right? But really, what we try to do with this architecture is to show that there are intelligence that has to be done at each layer. The silicon now has more intelligence than ever before, at a much lower cost point. You want to take advantage of that intelligence, all right? But it's not sufficient. It's essential, but it's not sufficient. You need to be able to augment that. Just like with the mobile phone, we had a mobile application that was running on the mobile device. The device, the mobile phone, was limited by capacity. It was limited by bandwidth. It was limited by connectivity, all right? That problem is multiplied again 10, 100-fold, depending on the use case, when you're talking about an embedded sensor. So you can put all the intelligence you want in that device, that edge device, but it can't have everything that it needs. All right? It always wants more. It's like cocaine. You know, I always want more. You know, I get hooked to it. All right? And then you have that connectivity. And I can tell you that connectivity is a real issue. And this is one of the things that my team's really been working on. And we'll talk about some of the SDN stuff that we're working on right now, is that the network is too rigid. Traditional way that you connected things was very much, okay, I'm going to build a new data center. I'm going to go into another geography. I'm going to plan that out a couple years in advance. I'm going to extend my fiber. I'm going to extend my MPLS network. I'm going to have a bunch of skilled resources to set that up. Those days are over, all right? Think about some of the use cases with Internet of Things. I have an embedded sensor that's in a truck, and I want to manage where that truck is and help them by feeding them information about weather patterns and other things so I can direct that truck to wherever it needs to go. I can't be bound by that physical nature of the network, all right? This edge computing layer is absolutely essential because basically there were two independent worlds that grew up. You had the operational technology world. How do I do the plant operations? How do I manage the building? How do I manage the plant? Etc. all right? And then you had information technology. How do I manage information from my consumers to the applications, to the data sources? Those two worlds really grew up independently. And the way they communicated was somebody created a report and shipped it up, and somebody read it, and then they tried to interpret it and put it into the IT system. Or they had some kind of data in terms of tapes, and they took them on a truck and they brought them up to the data center. Right? Those days are over. Right? People want to be able to collaborate in real time. You need to be able to interact in real time. So that means if you look at what happened in the early days of the internet, you had this aspect of the CDN architecture where you had these edge pops that would deliver. So we had dial-up back then, right? Think about how slow speed that was. The internet would have never have taken off if everything had to go all the way back to the back-end system. So this ability to deliver things at the edge, deliver more and more intelligence at the edge, deliver content at the edge, do security at the edge, that edge layer is extremely important. And then as you go back to the back-end systems, you get to more of a traditional kind of data center kind of model. Now, what's important across all of those levels, those 7 layers, is this flow of information. I want to be able to effectively get the information from where it is to where it needs to be. But the other important thing is I don't necessarily want the exact same information in the exact same format to go all the way to the back end. I may want to append additional information as it goes through those layers. As it goes from the edge all the way up to the application layers, I might want to append more information. Wow, because I know from these devices this is happening, but I also know from these devices this other thing is happening. I want to correlate that information as it moves up. All right? I also might want to refine that information. Maybe there's localized things that have no value upstream. They only have value in the localized domain. So I want to take action on those localized domain, and I don't want to send that data up. All right? So that flow of information is absolutely critical. The other thing that's critical is the security. I've got to have security from the edge device all the way back into the back-end system. Now, what's really kind of interesting is if you look at traditional way people did security in the data center, you know, they had their outer firewall, they had their DMZ, they had their inner firewall. And anything outside the outer firewall is completely untrusted, right? Don't want to know what goes on out there. It's scary and dark out there. I don't want to know, all right? Once you got through the DMZ and got through the inner firewall, oh, everything's fine. It's nirvana, right? No problems, all right? That's not reality. That's the way our data centers are, but that is not reality. A lot of times attacks come from within. A lot of times you want to reach out and touch your consumer. You want to touch their device. You want to interact with that device, all right? Whether it's a phone, whether it's a tablet, whether it's an embedded system, all right? So that model has to change, all right? But at the same time, all of a sudden you're talking to a whole set of things that you never talked to before. Perhaps in another geography you never talked to before. Perhaps with protocols you never talked with before, all right? So you've got to have that aspect of the end-to-end security model. And then you also have to be able to manage that environment. So I'm going to talk a good bit about those 3 things of what we're doing. And we call them IoT foundational services. So remember what I was saying before, I don't want to be very prescriptive and define everything for everyone because that's not the way the world works today. But I want to have a set of foundational services that are easy to consume by easy REST-based APIs, and then I can use that and extend that into other more complex services as the maturity model moves forward. So let's talk about connectivity, all right? Connectivity is all about flexibility and efficiency, all right? If it takes me days, weeks to connect to more devices, then I'm not going to be prone to adding more devices. I'm just not, all right? I need to do things in a more efficient time and more flexibility than I have before. So the old, everything done by, a VPN, and you set it up as a separate group that sets up the connectivity. Connectivity needs to be baked into the service. It needs to be easy for you to basically have the service and you have the connectivity you need along with that. It's like Ragu, it's kind of in there. The same thing in terms of security. It needs to be end-to-end, but it needs to be not a separate thing that's added on, but it's baked into the actual service itself. It's part of it, all right? And so if you take a look at Must be the batteries going dead on this thing. So we have this aspect of these IoT foundational services, these composable services. What we want to do is make it easy for people to assemble services together. So not build everything from scratch, but assemble things together quickly and easily, and having those basic foundational services available. And it's all about an open ecosystem, all right? Because remember what I told you before, a litmus test of a successful foundational service would be, can somebody take this foundational service and create a more complex service that has greater value, all right? If they can't do that easily, then it's not a foundational service, all right? And so we have been spending a lot of time and energy in the IBM company around our Bluemix platform, which is all around our composable services. We had the Bluemix Playground at the Expo this week. And so that's our focus, is having this aspect of having the Bluemix environment based off of the Cloud Foundry-based technology that's in the open source as being the primary way we compose services together. And now we've added IoT foundational services to that. The other foundational service that we have is the software-defined network. So I talked a good bit about connectivity and security as being needing to be kind of baked in, being in the control of the solution developer. So the developer or the solution owner needs to be able to quickly get new connectivity to new locations, and they need to have the security in there. All right? And so SDN is a key element of that. All right? So we, with a couple of our partners about 2 years ago, created the open source project called Open Daylight. All right? So I now have 150 people that work under me, specifically focused on SDN inside the IBM company. And one of the main reasons why I took that group over was I wanted to bake in SDN capabilities as part of our Internet of Things strategy. Because I needed to be able to connect securely the edge of network to the back-end systems. And I needed to do that for networks that I didn't control, that I didn't own. All right? Different networks, depending on the type of industry. They may be Wi-Fi, they may be some kind of proprietary protocol localized. I can't control everything end to end, which means I've got to go to this overlay, this abstraction model with SDN. So SDN is a foundational service that we're also adding as part of the orchestration of the composable services that we announced. All right, I'm getting mad with this thing now. Come on. All right. So we also announced at the Intel Developer Forum back in September. We announced with Intel. Oh, great. Thank you. You saved my blood pressure. Right. We talked about trusted compute. All right. So in every single Intel silicon that's shipped in the last 3 years, they have this aspect of trusted compute. They have a trusted processing module, trusted execution technology that's in the device. All right? And basically what we did with trusted compute is we exploit that so that we can tell where the device is, and we can tell if it's been tampered with or not. And if you think about Internet of Things, you don't have a human at the other end. All right? So the traditional kind of user password model is not going to work. All right? The other thing you have to worry about is that a security issue could be that the device is not where the device is supposed to be at the time that it's supposed to be there. All right? These things can move. They're very small many times. All right? So you have to have this line of this chain of trust so you can ensure that you haven't had some kind of man-in-the-middle attack. People haven't masqueraded as the device. So it's a whole new set of security things that you have to worry about with the Internet of Things model. Now, we also have a set of security services, and you might have seen some of the announcements we had this week around our security services all being delivered on the cloud by way of software. So things like our Trusteer asset, which looks at fraud prevention and other types of threat mitigation. All right? And it grew up on the enterprise in terms of financial fraud and other kinds of things. And what we're doing is we're taking that technology and we're applying it to new use cases around the Internet of Things. All right. So we also have this aspect of, I talked about connectivity and security having it needed to be kind of baked in. It's just in there. It's like ragu. All right? It's in there. All right? You also have this aspect of scale and elasticity. People do not understand how to plan for an Internet of Things scale. All right? How many devices are there going to be in 6 months? How much data are they going to send? It's very difficult to know what the world's going to look like in a month, much less 6 months out. All right? And so the ability to build an architectural model which is a scale-out, loosely coupled, API-oriented model that I have global reach, I can deliver things at the edge, is absolutely essential. And then last but not least, having the aspect of data analytics so that I know exactly what the data is telling me, and I can do business insight from that. All right? And so one of the assets that we acquired, I also led the technical due diligence of this acquisition, is a company called Cloudant. It was a fully managed NoSQL database company. All right? Now, what was interesting is when we acquired SoftLayer, we had about 25 companies in the IoT space that were hosted on SoftLayer that were IoT companies. They were hosted on SoftLayer. They were part of the IoT ecosystem. And many of them utilized Cloudant. We had about another 50 customers that were in the IoT space that weren't hosted on SoftLayer but used Cloudant as the backend data repository. And the reason for that is it's a fully managed JSON data store. So a lot of the big mobile apps utilize the Cloudant sync technology on the mobile side that would sync back with the backend data repository. All right? And many of them had taken that model and extended it to Internet of Things. All right? So we have a lot of part of the SoftLayer ecosystem that we inherited. And in fact, at the IoT at the IDF, the Intel Developer Forum, I held an IoT Partner Meetup. It was like a speed dating thing, all right? So we had 175 people that came to there. They were in the IoT space, many of which were either Cloudant customers or they were SoftLayer customers. They might have been Intel gateway vendors, and they all met one another and started collaborating. So it was a very interesting thing. We had some very interesting solutions come out of that meetup. So a lot of successful marriages. So. And those successful marriages was because of the fact that it was important to have the right analytics at the right layer at the right time with the right actionable insight. All right? You can err in two ways. You can try to do everything localized to where the sensors are, and you have a limited scope of information. Sometimes a limited scope of information is exactly what you need, because you need to take action quickly, and it really doesn't matter if 10 other systems that you have over here, whatever they say, if this sensor is going bad and it's an important sensor and you need to do preventative maintenance, you need to take action right there. Right? Why do you want to send it back here and 20 minutes later find out that the sensors died there? Okay? At the same time, you don't want to have just localized action and only have that go back to the back and you have no visibility across a greater landscape. And what's really interesting is the combination of data sources. All right? If I get all this data from a particular set of sources that are a particular type, and I have these other sources that are giving me a completely different type of data, perhaps there's some collaboration, there's some synergy between those two. So in other words, A plus B equals C, right? Where C is the business outcome that really matters to me. If I look at just A and I look at just B, I come to a different understanding of what the data is trying to tell me as if I look at this as a whole. So again, this aspect of being able to go from the edge device and having the data be refined, be cleansed as it moves back to the back-end system. Some cases I'm going to respond right there at the edge, at the device. Maybe it's right there, localized in the sensor itself. Maybe it's at the edge compute layer. Maybe it's at some regional hub. Maybe it's all the way back to the back end. But there's a continuous flow of data. And it's not just a one-way flow. One of the things that's interesting is if you look at the kind of the web commerce kind of world, it's all, you got a content that's hosted, and you have lots of people that want to get to that singleized content. All right? When you look at Internet of Things, it's actually the polar opposite. You have tons of devices that are coming in, and they need to be able to get value of those devices. So you have all this little data coming in from all these different devices, not versus one big data that's pushed out to many different consumers of that. So this aspect of two-way communication is really important. And so we focused on delivering, we announced it at the IDF that we were going to do this, and then we showcased it at the IoT World Forum. And it's our real-time analytics engine based off of what we call our flow data stream engine inside of SoftLayer. And what it does is it provides a simple REST-based API so that any part of the ecosystem, whether it's an edge player, in other words, maybe an IoT gateway, maybe it's a data or an analytics company that's doing things at the edge of network, they can drop information through a REST-based API and it can flow to where it needs to. It can also obtain information that's coming from another source. So this aspect of collaboration, being able to send the information, quote, flow the information for where it needs to go at the time that it needs to get there, right? And so we have this open for beta. Over the course of the last year since the SoftLayer acquisition, we've done a lot of integration with our back-end data and analytics engines. So the aspect is to be able to get those vendors that are kind of edge of network, to be able to flow information back into our data and analytic engines, and be able to also flow information back to them, all right? So maybe some kind of business outcome, I want to change some policy on the edge that makes a difference on the localized domain. All right? It's all about that interconnectivity. It's all about that intelligence end-to-end and being able to flow that information in a secure and controlled way. And I can't stress enough this aspect of an ecosystem. There is so much innovation happening right now. If you look at the Gartner hype cycle, Internet of Things is at the top of the hype cycle. And I'm very entrenched into the VC community, and there are tons of VC money being poured into companies that are in the IoT space. Some of the companies are building things that are a part of wearable technology, as an example, which is right around the actual sensor, the device itself. You have folks that are doing things in the business context at that edge computing layer. And you have data and analytic engines that want to be able to synchronize information from the edge all the way back into the back-end systems. You have security companies. So there's a massive amount of innovation that's happening here. And so if you compose solutions with the right model, if you have this composable solution model in mind, where you can basically assemble parts together, you can try new parts as they become available, you can replace new things, old things with new things as they become available, so that you're not locked into a very tightly integrated, tightly coupled kind of model, and then you can tap into the cloud. You see a massive opportunity that you can make a big difference in a very short period of time, and many times it's a very small company that has something very innovative that's really what you need versus perhaps something that's more complex. Because remember that model that I talked about with the continuous delivery, continuous operations model. I want to be able to excite my customer. I want to make that customer an advocate for my service all the way along the progression and the maturity. All right? I want to start small. I want to start consumable. I want to make it very simple services, foundational services that are very easy to consume, very easily to assemble, and very easily to have an ecosystem extend. And that's really what I call the perfect storm, because these things are coming together so that it's possible for you to go fast and far, and you can do so in a way that you're not locked into a particular technology, because the rate and pace at which technology moves, cloud speed moves too quickly for you to use any other kind of model and be successful. All right? That's just not my day for these clickers. All right, so I will be available for questions because we're out of time now, but I will be available for questions. I'll be hanging around the stage area for a while before you guys have to go off to your next session. So if you have questions, you can catch me there. Like I said, the first part of my presentation, the first chart, had my contact information, email, Twitter. That's the best way to get a hold of me is Twitter or email. Okay? All right, thank you very much. I appreciate it.